Welcome to Introduction to Video Security Systems, VSS, brought to you by Pelco. This course is a guide to the basics of Video Security System, VSS, camera principles. At the end of this course, the learner will be able to describe VSS camera principles. At the end of this section, you will be asked to complete a few assessment questions. There are many camera choices. It is a critical part of a system. If the camera is of poor quality, your images will be of poor quality. The video camera is the heart of any security system. Behind every successful system, you will find a well-matched camera, lens assembly, and an installer who is properly trained. This combination of a camera, lens, and installer will always be the determining factors in the overall picture quality of a system. The purpose of the camera is to convert a visual image into a series of electronic images. The information is then converted into an electronic signal that can be amplified and transmitted via a coaxial cable to the display link of the VSS. A pixel, short for picture element, is the basic unit of a CCD chip that accumulates charge depending upon the amount of light falling upon it. A typical CCD chip has over 300,000 pixels. The pixels are so close together that they appear connected. A charge-coupled device, CCD, is a light-sensitive chip or image sensor used in scanners and digital cameras that converts light into a video signal and delivers the signal to the monitor. The AD converter, analog to digital converter, converts analog signals into pixel values. A CCD camera is similar to a film camera, except that an electronic sensor replaces the film. The sensor is comprised of a grid of photodiodes that change the light that strikes the grid into electrons. These electrons are then stored in small wells or packets, which are read out as a series of varying voltages. These voltages are processed to produce a video image suitable for transmission via cable to a monitoring location. A lens gathers available light and focuses the resulting image on the chip of the camera. Lenses come in many sizes, focal lengths, and iris features. Choose the wrong lens, and you wind up with a poor or unusable picture. Adjusting the lens is also important for maximum performance. The iris opens and closes to control the amount of light passing through the CCD chip. A video picture, whether it comes from your television set, a movie projector, or from your home camcorder, is basically produced in the same way. A series of pictures are taken. Between each of these pictures or frames is the blanking period. Odd and even fields are interlaced to complete a single frame. The lines in a frame contain the information needed to form a picture. This new picture will occur at a time that is slightly advanced from the previously viewed picture. Interlaced video means that instead of using a whole frame of video information and presenting these stills in rapid succession to simulate movement, a frame is actually updated in parts over 2 slices of time. The first slice draws the odd number scan lines, and then the next draws the evens. When displayed, we see both the even and odd lines at once, and don't realize that one set is slightly delayed by 1 slice of time from the other. Rather than view whole entire frames at a lower rate of presentation that would flicker and have jerky motion, we can create the illusion of a smoother and sharper image by interlacing half frames. The downside of interlaced video is that fast motion may appear slightly blurred. Each frame of video consists of 2 fields of information. In a full frame, the image is made up of 525 individual scan lines, North American Standard, NTSC, and 625 individual scan lines, International, PAL. When the odd and even fields come together, it is known as frame interlacing. In order for a recorder to record longer periods of time, the number of frames per second must be reduced. This reduction causes a jerky motion playback or screen flickering. The signal used in video security systems, VSS, is called the composite video signal. It is a video signal consisting of all the data necessary to display a video image. It contains the video signal, the horizontal sync pulse at the end of each line, and the vertical sync pulse at the end of each frame. The voltage output of the signal is 1 VPP, 1 volt peak to peak.